Hi, welcome to Sruthi Lakshmi's Spiritual Classroom. Today we're going to see Problems on Trains, Part 2. Today we're going to focus on trains moving in same direction. Let's see two trains of same or different lengths. The first train's length is considered as L1 and second train's length is considered as L2. As you see, they're going in the same direction. And let's consider the speed of the first train as S1 and the speed of the second train as S2. Now it says the time taken to cross each other completely. So we have to find how much time it takes for these two trains to cross each other completely. So we have to do relative distance divided by the relative speed. The relative distance is the sum of both the train's lengths, so L1 plus L2, and the relative speed is when you subtract both the train speeds, so S1 minus S2. We subtract both the train speed because they're going in the same direction. So if they're going in opposite directions, we do S1 plus S2. But since they're going in the same direction, we do S1 minus S2. The first train's length is considered as L1 and the second train's length is considered as L2. And the first train's speed is considered as S1 and second train's speed is considered as S2. And time is relative distance divided by relative speed. So the distance is, for example, the distance over here is 200 meters and the distance for the second train is 150 meters. So we have to add 200 meters plus 150 meters for L1 plus L2 because it's the relative distance. And now for the relative speed, we do S1 minus S2. So S1 is 40 meters per second and S2 is 30 meters per second. So we subtract them. So 40 meters per second minus 30 meters per second. Let's see a few problems for easy understanding. Problem 1. Two trains 65 meter and 70 meter long are running on parallel tracks in the same direction with a speed of 136 km per hour and 100 km per hour. How long will it take to clear off each other from the moment they meet? This is the first train which is running at 136 km per hour and has a length of 65 meters. And this is the second train which is running at 100 km per hour and has a length of 70 meters. The first train's length is L1 which is 65 meters and the second train's length is L2 which is 70 meters. And the first train's speed is S1 which is 136 km per hour. And the second train speed is S2 which is 100 km per hour. We have to find the time. Time is distance divided by speed. So for the distance, we have to add train 1's length with train 2's length. So L1 plus L2. So 65 plus 70 is 135 meters. And now for the speed, we have to subtract S1 minus S2. So 136 km per hour minus 100 km per hour is 36 km per hour. The total distance to be covered by the two trains is 135 meters and the relative speed of the train is 36 km per hour. So we have to convert this kilometer per hour to meter per second. When we convert kilometer per hour to meter per second, multiply 5 by 18. So 36 into 5 by 18 meter per second. When we simplify this, we get 10. So the relative speed of the train is 10 meter per second. The time taken by the train to clear off each other is the sum of length of trains divided by the relative speed of the trains. So the sum of length of trains is nothing but the total distance covered by the two trains, which is 135 meters, and the relative speed of the train is 10 meter per second. So it's time equal to 135 divided by 10, which is 13.5 seconds. So it will take 13.5 seconds for the two trains to clear off each other. Let's see another problem. A train sets off at 1 p.m. at the speed of 80 km per hour. Another train starts at 2:30 p.m. in the same direction at the rate of 95 km per hour. Now you need to clearly notice the first train started at 1 p.m. It is running at 80 km per hour, whereas the second train is still. And it is going to start at only 2:30 p.m. So now the time when train B starts at 2:30 p.m., we need to find the distance train A has covered when it runs at 80 km per hour. So when it is running at 80 km per hour, and it will run for 1 hour and 30 minutes. So we need to find the distance it covers in 1 hour and 30 minutes. We know in 1 hour it covers 80 km, and in 1 hour and 30 minutes it's going to cover 120 km. So the question is, at what time will the trains meet? So we have to find when train A and train B meet each other. So this is how it will look when they meet each other. Distance is speed into time. The distance covered by train A at 2:30 p.m. is 80 km per hour into 1.5 hours. We can rewrite 1.5 hours as 3 by 2. So it's 80 into 3 by 2. So the relative distance is 120 kilometers. And train B at 2:30 p.m. it has traveled 0 kilometers. The distance covered by train A and B at 2:30 p.m. is 120 kilometers, because 120 kilometers plus 0 kilometers is 120 kilometers. The relative speed is S2 minus S1. The second train speed is 95 km per hour, and the first train speed is 80 km per hour. So it's 95 minus 80, which is 15 km per hour. So the relative speed is 50 km per hour. So we have to find the time taken to catch up with train A. So it's relative distance divided by relative speed. As we know, the relative distance is 120 kilometers, and the relative speed is 15 km per hour. So we divide 120 divided by 15, which is 8 hours. So we have to do 2:30 p.m. plus 8 hours, which gives us 10:30 p.m. So both the trains will meet each other at 10:30 p.m. Thanks for watching.